Sir, hello. Sir, hello.
Girish garu.
Hi, sir. How are you, sir?
I am fine, sir. How are you, sir?
Yeah, I'm doing good, sir. Thank you. Thank you for accepting our invitation, sir.
Yeah, it's my pleasure. It's my...
Yeah. That IIF AP forum convener will shortly join. He told us to continue. He'll come in the middle. Okay, sir. We'll start the program, sir. Yeah. So, yeah, students, Pujita, proceed, please.
I warmly welcome you all again to today's national program on the role of structural engineer and sustainable structures, organized by the Department of Civil Engineering, Sri Vishnu Engineering College for Women, Bhimavaram, in collaboration with Industry Institute Interaction Forum.
Now, let's have a keynote talk on role of materials and factors affecting the performance of concrete and approach towards sustainable and durable structures by Dr. Ravikumar B. Dr. Ravikumar B, by profession civil engineer, and completed his BE Civil from SRKR Engineering College, Bhimavaram, Andhra University, MTech from JNTK, and later completed his PhD from Geo Engineering Department, Andhra University. He associated with predominant multinational companies. He is a key contributor and successfully handled various wings of QA or QC execution and operations for the most prestigious and unique civil engineering projects like National Highway under NHAI power plants, high-rise towers, and construction of the new capital city Amravati. He delivered more than 43 guest lectures on various topics of concrete technology, building materials, and construction practices, quality assurance at sites, and also nurtured services as an external examiner for conducting the Viva Voice for the students of Civil Engineering Department in almost all leading engineering colleges and universities in Visakhapatnam, Vijayanagaram, and Vijayawada. He organized and participated more than 12 international and national conferences, seminars, workshops. He is a lifetime member from Indian Concrete Institute, ICI, Vijayawada chapter. Hereby, I would like to hand over the session to Dr. Ravikumar Garu.
Thank you so much, ma'am, for your kind words and warm welcome to this event. So, first of all, let me thank Sri Vishnu Engineering College for Women, Bhimavaram, and Mr. Dr. Girish for giving me this opportunity. As always, I used to have a good interaction with Dr. Girish. And in this time that I want to thank our engineer Prakash Rao sir also, who is later joining. So always I'll be having a great pleasure to interact with Dr. Girish. This is my third webinar for the same SVEC college. So I hope each and everybody is very fine during this pandemic and during this unlock also. So people are gaining more knowledge to this, through this virtual mode, and they are utilizing the best time. So that I don't want to take much of time. We will directly go into the presentation. Just I am sharing my presentation. Is it visible?
Yes, it is visible, sir. Please go on.
Thank you. Once again, a warm welcome to you all for the webinar on what today's topic, role of materials and factors affecting the performance of concrete. Earlier, we used to talk about, as a civil engineers, till a decade before, we used to talk about only the strength of the concrete. So that is the reason everybody got a comma there at strength of concrete. If the concrete attains its strength, then we thought, okay, everything went well. But from last 2 decades, the performances of concrete is becoming more and more predominant for the structures, for attaining a durable and sustainable structures for the better world. So that my topic will be on today, role of materials and factors affecting the performance of concrete. This is towards an approach for sustainable and durable structures. And Today content will be briefly, these are the contents which I want to cover. So as basically I am from a Ultratech Cement Limited unit, Ultratech Concrete. So a brief two slides for my introduction of the company's profile and what is the history of concrete and what the recent revolutionary changes occurred in the construction industry that affects the phase of construction, and durability of the concrete and what are the elements important to get the durable concrete, and revolution in concrete industry, factors affecting the durability, and how the selection of raw materials will play a major role for getting the durability, and what is the blended concrete and what are the advantages, and the QTC triangle principle, and what the workmanship, and with some of the, as we used to go daily 3 to 4 sites we have been visiting in our core job profile, so that I am going to show you various pictures which that where various sites the workmanship is lagging, and because of that how we are affecting the structures and innovative concrete products, and finally what is the 10 C's of concrete, and with conclusions today I want to conclude the session. So quickly I'll wrap up the session. And we are the largest producer of the grey cement, white cement and ready mix concrete in the pan India, and we are having an 113 million tons of capacity per annum with all our cement manufacturing units, and we are having more than 100 plus ready mix concrete plants in 36 cities, well established centralized batching plants for giving the tailor-made products to their customers, whatever the customer required, whether it is a specification concrete or product-based concrete or performance-based concrete. We are having all tailor-made products readily available with our hand, and we are supplying a huge quantities of concrete for the better building of the nation. So coming to the history of the concrete, actually the Portland cement PC invented by J.S. Espidin in 1824. He is an core engineer at the from England. So he has invented the Portland cement. Why that Portland has given the name? In that area where he stays, there is a rock, a natural rock which resembles the surface finishing of the cement. So the Portland name has been given to the cement, and from ancient days also we are used to call the ordinary Portland cement. And the concrete, nowadays the biggest consumption by the man-made is food industries. After the food industry, the highest consumable product by the man is the concrete for various aspects of the structures or individual house buildings, projects and mega structures, so that the second highest and largest consumable product in the 20th century is the concrete. And later the relationship between the water cement ratio, degree of hydration, porosity established by Powers in the year 1964. As earlier first slide I have discussed what is high strength, and actually that phase we just crossed it from strength concept to the performance concept. So high strength is not necessarily the high performance. High performance concrete is basically designed to get the durability. Durability is nothing but the longer life of the structure. So durability of the concrete. Eventually our structures we have been designed for a certain life period without any proper, without any attention, without any serviceable to the structure. Every structure has its own life to attain up to some extent. So generally our RCC structures built for a service of 70 to 100 years. But nowadays when we can see, this is actually we can take 20-30 years back, whatever the construction industry is there. Earlier at least we used to get 50 to 60 years of life of the buildings, but nowadays because of the lot of changes in the atmospheric conditions, construction technologies, parameters of the raw materials, the life of structures became deteriorated after 30-35 years. So that is where we all civil engineers has to attack this problem, and we have to be give a better solution how to increase the service life of the building. You can imagine that we have designed, we have given a structure, we have constructed, and we are expecting that a building will sustain for a period of 30-35 years. If we have taken enough care during the construction activity, post-concreting, pre-concreting, and after also whatever minor attention should be taken care for the structures, the life above the 35 years which we have designed, it may come to for 35 to 40, 45, the extra life, the attained by the structure rather than the standard service life, that extra life, that extra span will be called as the durability of the structure. So the simple definition for durability of structure is the period that attained over and above the standard life cycle of the structure or building. So concrete, as all of us know, concrete is a combination. It's a simple definition that combination of cement, water, coarse aggregate, sand, fine aggregate, and admixtures. Following are the factors that will affect the concrete for getting a good quality. That means variety and type of materials based on mixed proportion and batching. Why? Because we used to produce concrete in two methods. One is site mix concrete, one is ready mix concrete. So how the mixed proportion is being taken care and how the batching of concrete is being taken care at the RMC plants, and the environmental effect and the construction practices like workmanship, in which technology you are going to construct your project, and target object of the concrete. What is the target objective? Target objective is nothing but the grade of concrete and what is the workability required and what is the time to start the concrete and to finish the concrete. These are all the factors that gives the concrete a good quality concrete. But if we miss any of these factors, the immediate the properties of concrete which will get affect is the following properties may get affect because of the factors has not been considered or not treated well. So that may causes strength, getting low strength, workability, cohesion, and durability. So these are all the factors. But what are the elements that will affect the concrete durability? So we are now discussing about not a standard concrete. We are purely talking about how we get the durability and how we get the life of the structure above the standard life. So these are the durability factors, the concreting system, and the aggressiveness of the environment. So concreting system is again bifurcated into materials and process. Why? Because without materials we cannot produce the concrete, and the process, how materials like what is the binder type. Binder is nothing but our cement content. Binder content, how, what is the amount of binder content you are going to impart in your mix design, and what is the quality of aggregates, and what are the type of admixtures which you are going to use, and what is the mix design, whether it is designed for M20, M25, and whether it suits as per the codal requirement is not. These are all comes under your mix design and materials. And the process is nothing but how you are going to mix the materials, how you are going to transport, and how you have to place the concrete in the element, compaction, curing, temperature, workmanship, and the aggressiveness of the environment. These are all concrete system. This will be under control. Why? Because materials we can control, process we can control. This is exclusively we can correct all the concrete system. It is lied within our hands. But whereas the physical and chemical properties which affects the direct durability, it is not at all uncontrollable. And for that, what are the remedial course of actions? Later coming slides we can discuss. So simple physical properties like abrasion, erosion, cavitation, freezing, thaw, it is cold concreting, like chemical leaching, expansion, and alteration. So the process of construction has changed in ancient days. Earlier, it is simple a load-bearing structure. Like earlier, it is no simple. They'll dig the ground as per the sizes, and simple they'll construct the brickwork or whatever masonry work. Above that, on the base of the brickwork, they used to construct the buildings. Later, that from load-bearing to industry shifted to the framed structure. Framed structure is nothing but our columns, basically starts from footings, plinth beam, columns, slab. From the slab, it is a symmetric structure. That entire frame, first we will construct the frame or skeleton of the structure. Then we will go for the other machinery and other conduit works. And even now from framed structure, now the industry has shifted to monolithic construction. Monolithic construction is nothing but the simple definition. What we can say is monolithic construction is if once we have planned and scheduled a time to complete a slab area or whatever wall area element, once the concrete has started, it should be finished off without any joint or without any obstruction during the laying of concrete. Once you have started the wall, immediately, if you have started the wall, it should be finished without any joints, without any time delays. So that is called the monolithic construction technique. So as well as earlier, we have used it for this site mix concrete. It is purely based on the volumetric analysis, like 124, 136, like 148. That is the volumetric analysis of the site mix concrete. And whereas ready mix concrete is purely based on the IS 4926 codal practice with weighment analysis. So for 1 cubic meter of concrete, we will convert entire volumetric into weighment analysis. So how many kgs of cement you require, how many kgs of aggregates you require, including fine and coarse, and how many kgs of minimum water cement ratio, everything will be defined and everything will be as per the tables given in the codal practices. So ready mix concrete, now we can see a lot of activities. Even ready mix concrete also has shifted now into the precast concrete. It saves a lot of time with the precast concrete. We can cast our elements, whatever wall elements, even footings, beams, columns, everything we are casting readily available at the precast yards and transporting the element and fixing the elements onto the structure. This is the precast technology. Now adequately the precast technology is well into the construction industry. So what is the revolution in the concrete industry? As you know, even in 2-tier cities and 3-tier cities also, now the apartments culture has been very well suited, and the real estate boom is now looking for high-rise buildings, and huge competition is there in the high-rise sector. In order to stay this competition, the builders or whatever the developers are hard pressed to complete the project as fast as possible. One builder, you will think, okay, my co-builder has constructed 11 floors. I have to construct 15 floors. I have to construct 20 floors. Like that, a big competition that has resulted knowingly or unknowingly, where the builders or whatever civil engineers or engineers violating various building norms, so that that entire violation leads the failure of structures, and even the structures are unable to attain the at least the designed service life of the structures. So the Indian construction industry earlier and now, earlier days, there is low demand for construction, and government is also spending low on infrastructure. But whereas you compare with now, as you are seeing that AP TIDCO projects, the Prime Minister Awas Yojana, like that, all schemes, it is mandated to have every family should have one double-bedroom house. So that is the process, or that is the aim of the government, so that every family should have their houses. And availability of land also adequately available earlier, but nowadays the land availability is much coming narrow, and that is the reason also the prices are being high. Shortage of cement is there earlier, but now, as I said earlier, we are being in 113 million tons capacity per annum. So the surplus cement production is there. So the labor is also cheap, but nowadays the labor availability is being the most toughest job for us as an industrialist to getting the skilled and semi-skilled labor. As because of this migrant labor in this pandemic situation, daily our toughest job, how to get the manpower into act. So these are all the construction industry. What earlier in India, now what the construction industry in India is looking at. Need for faster construction and sustainable and durable construction, latest technologies. Even we have been appointed multinational consultants from Singapore and all these countries for our better durability structures. We have been various countries has been involved for getting a good quality of buildings. So these are the present trend in the construction. Modern structure. Everybody wants the modern structure. They don't want to compare each individual. And the structure, it should be tall and it is slender and thin walls. Thin walls is nothing but entire, as you have shown the monolithic structure, the walls is also casted with the concrete so that the brickwork machinery works can be eliminated. So thin wall, that is with my1 shuttering, and design for higher stresses. Why? Because to get the project in time, they are looking for high quality, high strength concrete, and the structure would undergo some high stresses. And all these, the basic aim of this trend is to construct at a fast pace. So revolution of making concrete over decades. Over decades, now the standards have been given that normal concrete we can use up to M20 grade, what we call as normal concrete. Even the IS 456 has in the recent revision, M20 is also should be taken considered as a plain cement concrete, not an RCC, if it is in a pure coastal region. So then standard concrete, the M25 to M35, and high strength concrete. What we will say normally M40 and above will denote as that is a high strength concrete. For various buildings that and various projects, they require M40 and above concrete. Then the concept of high performance concrete, as we didn't stop at the strength part and we are looking at the performance concrete, then the blended concrete is came into life and extensively it is giving a better result. With blended concrete we can get the best durable structures and special value added concrete products. This is purely on the application and product based. If you want some specific requirement in the project, are you having a specification, it wants some ample product, so we can produce that product based on the customer requirement and we will supply the concrete. So coming into the details of today's presentation, what are the factors affecting the durability of the reinforced concrete? So these are all the following major factors which will give and impose the life cycle of the building. That is, one is design deformities, environmental conditions, sulphate and chloride attacks, corrosion of reinforcement in the concrete, carbonation and leaching effect, alkali aggregate react, thermal damage, plastic and dry shrinkage cracks, joints, and quality enhancement of concrete using blended materials, and finally the workmanship. We'll just go through one or two slides of the each component so that we'll having a brief idea about what are the factors that affecting the durability of the structures. As coming to the design deficiencies, actually in the case of planning itself, while we are as a civil engineers or whatever the structural engineer or an architect, first they should study what is the design that required for the structure and what is the tensile strength and what is the compressive strength it requires, so that both can give the strength to the building. So it should taken care the entire load that is coming onto the structure. Why? Because in some cases you can see the building will be and almost all you can see in the metro cities or in type A tier cities, after finishing, the owner or the developer, they used to give the terrace on lease basis or rental basis for huge hoardings. So these hoardings weight and the wind load and the dead load will not be taken consideration by the structural engineer while in the design aspect. So these are all estimation of load should be done properly for any structure to be designed. So in the same applies for the earthquake intensity and zone and wind velocities, and ultimately the entire design should be done as the total load of the structure, including dead load, live load, wind load, whatever may be the A to Z loads, that will be taken care by the soil. So that first, sure, we should be done. It should be done for the bearing capacity. What is the safe bearing capacity of soil? Based on that soil load bearing capacity, we can design how much floors you require and what is the total load. If the soil is not sustainable to take the load, then we have to go for various foundation techniques like pile foundations, individual footings, combined footings, rafts, like that. In design aspect, it should be taken in-depth precautions for the design of the buildings. And in design also, we have to see what is the cover depth and crack width. Both also gives the major play. Why? Because once the whatever maybe the precautions you have taken for construction of your building, once the crack, why? Because these are all factors which is non-tangible and we cannot identify. Even after the structure, it will take continuous loads throughout the entire designed period. So we cannot assess what is the stress that is a structure is being facing. So these two factors can be taken an adequate care. You can just see the photographs. The proper cover is not given to the slab. So after de-shuttering, this will be the condition of the slab. So definitely we are giving whatever may be the remedial course of action done for the damaged portion. It won't embed itself and it will not act as a single element. Both will have an individual elements, individual stresses, so that in every year and year on year, it requires the rectification. So for this normal cover, as clearly has been given in the IS 456 codal specification, based on the 5 severe conditions. As we have to, when we are taking care in the design aspect, we have to consider what is the criteria that the structure or the soil it will take. It will come in, into the exposure condition like mild, moderate, severe, very severe and extreme. Based on this exposure conditions, we should finalize the cover to the main reinforcement. If it is mild, okay, a 1 inch cover or less than 1 inch cover, it may sufficient to the structure. But whereas in moderate, it requires minimum 30. Like that, severe 45 and very severe 50. Extreme severe in the case where the constructions has been done underwater constructions or under sea construction like ports and all these projects, it is falls under extreme conditions and we have to go for 75 mm cover also for the reinforcement. So environmental exposure conditions will play a greater role on the durability of the structure. Why? Because concrete is the most vulnerable or first affected element in the entire structure when the aggressive exposure conditions and the severe climatic conditions will impose the concrete surface to get deteriorate fast. So as we already discussed about these 5 exposure conditions, environmental exposure conditions, based on these exposure conditions, the design criteria should meet the requirement of the life cycle of the building. So coming into the sulphate attacks. So as sulphate, it is in the form of calcium, sodium, potassium, magnesium, and all these are all naturally occur in the groundwater. Even in soils also, some of the soils like you can see in any industrial area, definitely because of the effluents coming from the industry, the groundwater may get affected, and eventually with the groundwater, the soil which is holding that water, it also get contaminated with all these chemical contents. So that solid sulphate will not give any impact. If that is the reason we are giving our footings, we are directly excavating, constructing a footing, again immediately we are backfilling the footings. So even at that area, the sulfates or whatever may be the chemical contents, it is in the solid form. So this solid form will not get that much effect to the structures. But whereas when these are all contents, when mixed in water, and if water is being percolated through our structures with the porous and weak junction, then definitely the sulfate attack will cause a big problem to the structure, and it will increase the volume of the cement paste. So you can see why, because when we are designing, consider what is the ASC and ASC. It is nothing but area of steel versus area of concrete. If the bulging of concrete occurs because of the sulfate, then definitely the concrete surface will deplete from the reinforcement, and it is departed from the reinforcement. So this, because of this increase in volume, the gradual disintegration of concrete as the sulfate attacks on the reinforcement, gradually the dilution of the concrete get place, and it will start at a slower place, but after some period the effect will be more. So it is to be noted that sulfate is the most potent enemy to cause the lack of durability of the structure. So in IS 456, it is clearly mentioning about what are the permissible limits, even in the water which we are mixing in concrete and the water which we are doing curing. So all these limits has been clearly mentioned. So methods of controlling the sulfate attack, uses of blended concrete, that is OPC. We can go through detail in the next slides about this blended concrete. So quality of concrete, low water cement ratio, well designed and compacted for dense concrete. Once the concrete is properly compacted, so the entire entrapped air will come out, and you will have a dense and solidified concrete, so that it won't allow any water to percolate through the element. So use of pozzolana, high pressure steam curing. So coming after sulfate, these are all the twins which affect the concrete to get more and more deterioration at a faster phase. One is sulfate and the second one is chlorides. Chloride enters the concrete from consistent material from ingress and diffusion from environment. As environment, we are having chloride attacks the protective porosity layer, which is self-generated on the surface of the steel in the hydration process. Once the hydration process is nothing but when H2O, water, is get contact with cement, immediately the hydration, the endothermic reaction will start, and the hydration action impose a cement paste. That layer will form over the steel. As a result of corrosion, the increase in volume surrounding concrete get damaged. So these are all the limits that has given up to 0.2% by weight of cement, chlorides, no risk of corrosion, and 0.2 to 0.4 low risk, 0.4 to 1% by weight of cement, moderate risk. If more than 1% by the weight of cement, then if the chlorides are more than 1% by the weight of cement in a mixed design, say for example, you are using 300 kg, so 1%, 3 grams or 3, this one, this gives the high risk of corrosion. So as once the corrosion starts, corrosion is nothing but what we can say, it is nothing but a cancer to the concrete. So this is the phenomena how the corrosion will place. Is simple, as we can say the reinforcement will have an tested with an anode and cathode method. So the H2O gets reacted with our cement, and this ferrous Fe oxide, it will develop more and more. Once the repeated anode and cathode ionic action, it gives more ferrous oxide. It will nothing but it will an enemy to the reinforcement which got the corrosion. And even once the single oxygen to entire this thing, the corrosion plays a major role. So see the volume, if you can have a look, what is the ferrous and ferrous oxide and all these elements, and year on year, once the corrosion will start with a single Fe ion, so after getting hydration action, it will react with the moisture and the ferrous oxide, like that. Once the volume goes on increasing, so your condition of corrosion will get more and more, and after some time the corrosion only we can have the impression of the steel on the slab, not on the corrosion. Entire it will get rusted and it will fall down. So how to get rid of from this corrosion? Making a good concrete, adopting low water cement ratio, good compaction for concrete, curing practices, using correct admixtures. Why? Because in some of the admixtures also they will be having some suspended chlorine content and chloride content and sulfur. So use of correct admixtures for the correct cement what you are using, you have to check for the compatibility test for admixtures versus the type of cement what you are using. Adequate cover. Why? Because the more the cover, more the lifespan of the structure, and it will attack the anode and cathode reaction will start. Even though the cover is more, then the time to reach the reinforcement will be dragged and will having at least a better life of the structure. So then coming the next major element factor that affecting the concrete structures, which disturbing the durability of the structure. The carbon dioxide from the air reacts with the calcium hydroxide to form calcium carbonates. In presence of the moisture, this acid is formed which reduces the alkalinity of the concrete. So if the pH value of the reduces concrete generally from 12.5 and above, when it is coming down to 12.5 to 9, if the pH value comes down, then it is immediately it will affect the protective layer of the steel. So thus the carbonation action immediately starts and it deteriorates the steel. So as this is the some of the studies done, depth of carbonation versus age. For the M20 grade, within 2 years that is 5 mm, whereas M40 grade 0.5. That is the reason now people are looking at a high grade and high strength concretes. As in 50 years, if you can imagine that life cycle of the building is 50 years. With the carbonation action done because of the calcium carbonates, 50 years, the depth and effect will be 25 mm. Whereas if you can use for higher grades, the depth is only limited for 4 mm thickness. So this is the one of the standard testing procedure. You can see the pink color area till now not affected by the carbon dioxide, whereas the rest, the chemical will it's not given any color. It remains same. That entire portion is affected by the carbonation. So methods of controlling carbonation. The highest rate of carbonation occur at a relative humidity between 50 and 70%, whereas the humidity plays a major role. None of them will not considering this factor, that humidity factor. What is the humidity? What is the wind velocity on pouring day? It will place a major role. And the protective coating is required to be given for long span bridges, flyovers, industrial structures and chimneys. Why? Because these are all structures which will undergo all 365 days some chemical action inherently in between the structure. So depth of cover plays a major important role in protecting the steel from carbonation. So next major effect is alkali aggregate react. So alkali content in cement that reacts with reactive silica of aggregates. What the aggregates we are using for manufacturing of the concrete, thus alkali content of the cement react with the silica of the aggregates, then the gel forms, both will mix and the gel forms. Once after the manifesting of this gel, it will allow the bulging of concrete and gives the crack. The once, as you know, the crack is the first door to allow our structure is going to deteriorate at a faster rate. So occurrence of alkali silica reactivity due to high alkali content in cement as per MTCR specification, it is saying only it is limited up to 0.6% is allowed. Reactive silica, why? Because we cannot control the silica content in the aggregates, as these are all natural products which we are crushing and using. So what is the remedial action measure to take the alkali aggregate reaction? Use of non-reactive aggregates from alternative sources. If the aggregates is having more prone for this silica, so that we have to go for other source of aggregates or raw materials, or low alkali cement, reduce cement content in the concrete, use of pozzolana, slag or silica fume, control on service condition, limiting the degree of saturation of the concrete. The saturation condition, once the concrete placed, it immediately after 1.5 hours, when the hydration action starts, then it forms green state to plastic state and plastic state to hardened state. In the phenomena, it will go some that silica reaction. So the degree of saturation of concrete plays and also a major important role. This can be controlled by using a proper admixtures. So effects of leaching. So you can see in all our buildings also, if untreated at the soffit of the slabs, we can see white color patches will be coming. This is nothing but the leaching. The free lime, which is in the concrete, it will come out after a certain period and it will deposit on the surfaces of the concrete elements. So calcium hydroxide is one of the product of hydration. Once the hydration action starts, the calcium hydroxide CaOH twice, it does not contribute to this tank, but it is a product or an residual after the hydration action. It remains as it is same. So it after some time, if it is untreated properly or it is unutilized properly, this calcium hydroxide is coming out on the surface and convert into the cementitious product, which is used of the pozzolana material. So coming thermal effect. So the temperatures while placing the concrete for huge massive pores, then definitely the thermal effects, which is the exothermic, both endothermic reactions occurs in the massive pores, definitely will affect the concretes. This can be controlled while pouring the concrete by considering the temperature of the concrete and by cooling the aggregates and placing temperature. All these things will affect to control the thermal damage, which is going to give a major effect for the durability of the structure. So thermal cracks develop if the temperature difference between the core and surface of the concrete is more than 20. You mean, see, you have given a 1.5 meter depth of raft you have poured. We will always look for the surface of the concrete. But what is the temperature? It is there inside, inbuilt in the concrete at the bottom layer. That also plays a major role. That is the reason when massive pores are coming, are being taken care. So we have to look for there is no joints and there is no cold joints, and we have to look for the temperature should be well within 27 plus or minus 2 degrees temperature. We should maintain the concrete while pouring the concrete. For that, what are the remedial measures? Chilled water, ice flakes, pre-chilling aggregates, use of low heat cement like blended concrete. In insulation of concrete, in insulation is nothing but we have to cover with thermocol sheets or PP sheet covering, so that the temperature which is coming directly from the atmosphere and the core temperature inside the raft, it should not be more than 20 degrees, and we have to maintain the temperature. Then only the structure will have more dense concrete, and it gives a more and more durable lifetime to the structure. Then the major, as we are always discussing about cracks. Cracks is the major major prone areas where the concrete tends to crack. There is a scientist there in the civil engineering industry. Good concrete always cracks, but how to mitigate these cracks, or how to limit the plastic shrinkage cracks or dry shrinkage cracks or settlement cracks will go. What is the freshly placed concrete? It loses its water because of the internal hydration action. It gives the temperature and the loss of water. The hydration is nothing but in summer also, being a human beings, we lost our salt and water. Immediately what we'll do, we'll take some ORS, or we'll take some liquids to compensate whatever the evaporated or whatever the losses of salts and water. The same phenomena, concrete tends to lose the volume, and it results the shrinkage. Shrinkage in that it will shrink, so that during this phenomena, concrete will undergo some stress, and ultimately when the concrete turns from plastic state to hardened state, the settlements will not be borne by the concrete, as you have to treat the fresh concrete is like baby. It cannot take more loads. In any undergone stresses, definitely it imparts the cracks which will form on the surface of the structure. So to avoid all these plastic shrinkage cracks, which will come predominantly while casting the slabs only. These are all plastic shrinkage cracks coming during the pour. So for that, immediately you have to take the following measures: to use of spray curing or early curing, and wind break should be given to avoid the wind velocities, early curing, and to have low water cement ratio and low slump, covering the finished surfaces with Asian cloth, and avoid placing of concrete on dry subsurface. Why? Because we have to, when we are placed on dry subsurfaces like roads, the element which is acting as a subsurface, it will absorb the water in the concrete immediately after placing on the subsurface, and it won't, the water remains water. What is the water remaining in the concrete after absorbing by the subsurface? It won't get react with the concrete. So that is the reason the plastic shrinkage cracks may occur. So next, coming to dry shrinkage cracks. Dry shrinkage cracks, by this picture only we can see the grapes in a fresh state, and after loses its water in the grape. Why? How the volume of the grapes and how the space between the grapes has been clearly denotes the same phenomena. Dry shrinkage, after losing the water volume in the concrete, it tends for cracks. That cracks is called a dry shrinkage. Similar to the hydration of cement, is also everlasting process. Dry shrinkage is an everlasting process. It is due to the loss of water in the gel pores and change in the volume. So the magnitude of shrinkage depends upon the cement content. What is the maximum cement content, and what are the constituents? Like, are you using any mineral admixtures, and any water cement ratio? What is the humidity factor? All this will affect your dry shrinkage factors. So remedial measures as good quality aggregates and prolonged curing for concrete is mandatorily done for at least, as the code is saying, minimum 7 to 10 days the element requires the curing. Why? Because as we are assuming the 7 days, it should reach the at least 2/3 of the strength design. So at least for a period of 7 to 10 days it requires curing. But even though within the next 2 to 3 days we are all forced to stop, because to take up the next phase of activity. And as I already discussed about, the temperature for pouring is 27 plus or minus 2 degrees Celsius. So these are the quality enhancements of using blended materials. In the past, OPC was used in only ordinary Portland cement, but in modern buildings, that fly ash and GGBS and micro silica, these are all called the mineral admixtures, which we can use so that the whatever what we discussed, that the free lime, that leaching effect we discussed, that calcium hydroxide which is untreated, this calcium hydroxide again reacts with the pozzolana material like GGBS. GGBS is nothing but ground glass furnace slag, and fly ash is a byproduct from the any thermal power plant by burning the coal in the plant. So the GGBS is a byproduct from the steel. So by utilizing these byproducts also, we are having an adequate advantage of eco-friendly and green building concept. Why? Because as the common factor or studies is saying, for manufacturing of 1 kg of Portland cement, 0.5 kgs of carbon dioxide is being released into the environment. So earlier days, we used to use only ordinary Portland cement. You imagine 300 kgs, then immediately 150 of the carbon dioxide is being released into the air. So how much the environmental is getting affected. To compensate, we are now code is allowing to use 15 to 35% of replacement for fly ash, and GGBS is for 70, is a minimum 25% to 75%. We can replace the OPC content. For that, the secondary gel, see, once the cement gets reacted with water, H2O, immediately hydration action starts, and CSH gel, calcium silica hydrated gel, plus our CaOH twice, that is free lime, calcium hydroxide, it is there in the chemical action. If when we are using this OPC with fly ash or GGBS, again the pozzolanic material in the fly ash and GGBS will get reacted with the calcium hydroxide, and it reacts into the secondary gel. So once the gel formation is more, the gel tends to fill all the voids or tends to fill all the gaps by giving a proper compaction. Once the voids and gaps in entire structure has been properly taken care, then there is no chances of air or water passing through the element. So that if you want to get a dense and durable concrete, mandatorily you should suggest that we have to go for only blended cement concretes. So for getting, as I discussed, this is the when OPC and hydration process, CSH gel plus calcium hydroxide, the free calcium hydroxide when again reacted with pozzolanic material and water, again that CSH gel will form. So these untreated under pozzolanic material will physically occupy the void space in the paste structure and reduces the pore size and further improves the packing effect. Once the packing effect is more and the void space is totally eliminated, then you can get a dense and durable concrete. So these are all the advantages with the blended concretes. So it has been demonstrated the best pozzolanic is optimum proportion mixed with OPC improves many quality of concrete, such as lowers the heat of hydration. Once the heat of hydration is lowered, then your plastic shrinkage cracks will come down drastically. So the plastic shrinkage cracks is not there, then there is no chances of water, moisture, air, anything. It cannot penetrate through that crack. And even it is good for the thermal effect in mass concretes, makes the concrete more impermeable, improve the resistance to sulphate and chloride attacks, improving the dilution and leaching effect, workability, and it gives and it enhances the long-term strength and durability, and also reduces the alkali aggregate reaction. And one more point I want to know, put a note here. If you are using pure ordinary Portland cement and after 28 days, if you are designed as, for example, you say for M20 grade of concrete, you have to use 300 kgs OPC. So after 28 days, when we get testing of that hardened specimen, we'll get definitely 20 or 25 MPa of strength. But after that, the lateral strength pattern will not be there, as the total entire pozzolanic material got reacted with water and the free lime is there untreated. But whereas when we use this blended concrete, the lateral strength at the age of 56 days and at the age of 90 days, we are having, if you test the same specimen with OPC and with OPC plus fly ash or GGBS, at the age of 90 days, it gives, for example, 28 days, it gives 100% strength. At the age of 90 days, OPC will give 115%. But whereas in GGBS and fly ash specimen, it gives 150%. So you will having an additional benefit of the lateral strength attainment. Though the selection of raw materials will also plays a major role for getting a durable concrete. As already discussed, we require cement, water, admixture, coarse and fine aggregate. We'll just quickly go through what are the factors. So as I said, cement that will impose and it will gives directly relates the compressive strength and particle size distribution based on the 90 micron passing sieve. Like aggregates, maximum size of aggregates, shape and structure, and silica content in the aggregates. Water, the potable, is it the water is suits for the preparation of concrete, and what is the pH value, and what is the suspended chlorides and sulphates in the water, chemical admixtures, mineral admixtures. These are all the constituent materials that used in concrete. So aggregates, as the aggregates will directly give the strength, as even code also saying 3 parts. One is what is the, you have to prepare a mixed code or you have to prepare a mixed design. These 3 factors. Number 1, what is the maximum size of aggregate you are considering for designing of a mixed code, and what is the maximum cement content, and what is the water cement ratio. These 3 parameters will directly impact your design criteria and load criteria. Load in the sense strength criteria. And as water, we already discussed what is the water pH values and water cement ratio. This is strictly we should follow the codal specifications to attain water for a better and good workability of the concrete. So chemical admixtures, these are all lot of companies is having these type of admixtures, type A, B, C, D. Water reducing admixtures, retarding admixtures, accelerated admixtures, water reducing and retarding. Why? Because if you want to, as we are having that the maximum cement content per cubic meter, it should not cross 450 kg. That is a standard. If it is a pure OPC, and we can go up to 500 to 550 kg when we are going with blended products. So if you want to get a M60 or M70 grade of concrete, and we are not allowed to increase the cement content, then the only factor which we are in hand is to reduce the water cement ratio. Okay, what happens when the water content in the mixed design is coming down? The normal consistency, it should attain minimum the cement, it should get react with water and it should give some paste. For that, it requires minimum of 28% of water. If the 28% of water is not given, it won't form a paste and simply it will form a lumps. So that is the reason the water reducing and retarding admixtures has came into the picture, and the polycarbon ether is the major core element in the admixture. It gives the workability of the concrete by attaining a strength at 0.2 to 0.3 water cement ratio. So these are all the mineral admixtures. We already discussed about ground blast furnace slag and lime, fly ash, silica fumes, all these things we already discussed. So coming major factor, workmanship. Workmanship is one of the most important factor responsible for the production of quality concrete and to finish the concrete. So we have discussed about batching, mixing, transportation, all these parameters. We require at least a minimum 100% workmen should be there to address the durability of the structure. You just see the mixed design, if it is not properly there, then You see, there is no 20 mm aggregate, coarse aggregate in the element. After breaking, after chipping, we used to identify that the column is not taken the enough load because there is no coarse aggregate mixed. So these are all the factors that will affect. Then to see the column as per the standards, the height of fall of concrete for pouring is not more than 1.5 meter. But whereas the columns are the board size of 2.1 meter, they are casted from top to bottom. So that is the case. If it is not properly mixed or not proper, it is not of that suits the workability, not properly compacted, the columns will get more honeycombs. And even though after that we do any remedial course of action, grouting or whatever, any carbon wrapping you are given, that won't be as a original element which should take the entire load of the structure. So you see that from top it is been casted, and after the entire we are staying at the residences or apartments, if the column gives such a crack, then it is highly difficult to get the rectification or get the job done. We cannot control, but these controls can be done during the concreting itself. You see, poor concrete cover, it gives the early deterioration of the slabs. And after sometimes, as I said, we'll having only impressions or stains of the steel only. It is no steel is not visible on the at the soffit of the slabs. It is only the impression of the steel. So cover, if the cover is not properly done, definitely our carbonation action immediately gets started with the atmospheric carbon dioxide, and the structure is vulnerable to get deteriorated at faster phase. You can see improper covers during concreting. So that is the reason you can see on the top of the slab also and the soffit of the slab also, we can observe the impression of the reinforcement tide. So improper supporting system, this also plays a major role. Why? Because it should be taken enough care for a period of at least 7 to 14 days. When the concrete, why the code is saying immediately test the 1 day and you can go for second phase of work. It is saying minimum 7 days and a period of 28 days. So during this 28 days, at least you can average up to 14 days. The load stress will be taken care by the structure. Once the concrete laid in fresh state, it won't give any importance or impart any load onto the shuttering system. But once it get hardened, then definitely it will impose the load to the shuttering. If the shuttering is not done properly, then it tends to fail, and obviously after rectification, whatever may be rectification done to the damaged portion, it won't give any result to the during towards the durability. So improper shuttering, you see, just imagine, these are all the tangible things which we can identify, we can correct itself during the construction activity. After that, these are all cannot be visualized, so that we will simply say the cement failed or concrete failed or the carpenter has done a mistake. But there is no post-mortem is available with civil engineers. Only that facility as given by God to only the doctors. If the case fails, simply they will do the post-mortem and simply they will with root cause how the case got filed. But in our civil engineers, that facility or that leverage is not given and not there, so that we have to take enough care during the concreting itself. So see the covering of gaps, shuttering board gaps. So these are all in hurry, and in the ease of getting the faster construction, these are all negligibly or knowingly or unknowingly doing by the laborer or workman who is directly placing the reinforcement and covering the rods. These are all the reinforcement bad practices which we cannot vibrate, so that definitely the dense concrete will not attain, and the structure is getting closer to the deterioration condition. So see, these are all the gaps which the slurry will pass from the gaps, and obviously your plastic coat of the green layer of the concrete will not come onto the surface. So it affects the structures. So, so you have to ensure this sort of shuttering system for a rigid and good quality of shuttering system. Obviously, it gives 200% assurance for getting a good and dense durable concretes. So these are all the my one shutterings, and a better shuttering scheme gives a better structures. So this is the quality time QTC triangle. You just note, I can have some play on this. Only two parameters will match, and the third parameter you have to compromise. If you want a quality structure and within how much time it will take, then you have to compromise cost. You have to be ready to put high and high cost for getting quality material and to invest time. So like that, if you want a quality building and with a how much cost also you are ready to put, you have to compromise the time. Definitely the project you are planning for 1 year, it may goes up to 1.5 or 1.5 year also. Like that, if you want I want a time constraint is there, cost constraint is there, I want to finish off the building, definitely only time and cost will match. You have to least bother about the quality of the product. So for that, we are having some innovative concrete products from a flagship of our Ultratech concrete. For each and every, what we are discussing about performance and product based. Aqua Seal, Lightcon, Free Flow, Dura Plus, Decar, Industrial Force, Rapid, Jeep, and Pervious concrete. This is the self-compacting concrete. Once my finishing of my presentation, I will go through the videos also. So with this self-compacting concrete, the high-rise towers of at Visakhapatnam are constructed, and even entire Amaravati, what the construction till now has happened, it is entirely with the self-compacting concrete technology only. So coming to the pervious concrete, it is also a why? Because now we can see in heavy rains or whatever the rain, it is a gift of God which we have to be protected for the next generation. So we are going unnecessarily also some of the parking areas and all the footpaths and pedestrian walkways, we are doing the impervious concrete surfaces. So if we can replace these impervious surfaces with pervious concrete, definitely the rainwater, it will percolate through that concrete and it will recharge the groundwater table. So this video also I will show you after the presentation. So various applications with pervious concrete, and as you see recent rains also, this is the condition of metro cities because of the improper stormwater management. So with this pervious concrete, we can do somewhat of this water can be percolated at that particular area, and groundwater table can be recharged, so that our next generation can see water can be brought from the ground borewell resources, not from procuring or not manufacturing at the factories. So that's what I mean to mention. Earlier we used to have the wells, then the ground upper bore wells, then the motor, electrical motor bore wells. But after some time, if the groundwater is not there sufficiently in the underground layers, then definitely 100% we used to procure water from the, it should be manufactured from the industries. So coming with this, to minimize the building failures, we have to do the proper soil investigation, study of groundwater table, no compromise on quality materials, accurate water cement ratio as per the grade of the concrete, and try to avoid fast phase of construction. Even if you want to go for fast phase of construction, you have to adopt the latest trends, latest shuttering schemes, latest construction methodologies you should adopt, and right supervision and correct implementation of the drawings without allowing any sort of deviations. So with this, the 10 C's of concrete would plays a major role for getting a good durable structures, that is consistency, that is materials, mixed proportion, compressive strength, compatibility, cohesion, consistency, cover, curing, crack resistance, and chemical resistance. With this, the conclusions are the imparting proper training to the workforce at sites regarding the latest trends in construction technology, and keen supervision should be there right from execution to finishing. The drawings and the shuttering scheme should be followed, and good construction practices should be adopted by using good quality raw materials and latest construction technologies like precast, the Maiwan shuttering, and even plastic shuttering is also well in advance in the Western countries. So these type of techniques we should adopt, and periodical maintenance by the maintenance should be done for the buildings by analyzing any deformalities. Immediately you have to go for remedial action and implement also safe and good workmanship in construction industry. So good quality workmanship of concrete or materials, what we have discussed, with good construction practices, definitely we can have a durable structures, because every construction is a different ball game. We cannot play tennis with a cricket ball, or we cannot play cricket with golf ball. So whatever the construction you are going to do or you are going to adopt, you should select the right design factors, right construction practices, good quality, right materials, so that definitely we will get the durable structures. With this, let us all joining for constructing better future by constructing the world-class durable structures. With this, just I am concluding, and just I want to show the video. Just 1 second, just I want to. Sir, is it visible, sir?
Yeah, the video is not visible, sir.
Yeah. This is what I want to show. This is free flow concrete. That is 18 meters of the length of the beam. And you imagine what is the live load, that manpower which has to handle the concrete. We have laid the entire beam with only 2 manpower. Earlier, there is a huge problem for the manpower. Now, the industry is facing a huge scarcity for manpower. So, the design of self-compacting concrete, by its own weight, it will flow and it will fill the element, so that the manpower can be eliminated and the vibration can be eliminated. So, any sort of deformities, because even if you give the excessive vibration also, definitely it tends to crack. So the vibration should be there, the compaction factor should be there. So with all these parameters, it has been invented like free flow concrete. And coming to the pervious concrete, which we have discussed for getting next generation's water tables at the ground level. So this is the pervious concrete. So once the rainwater, it will percolate from the pervious concrete element, and it will recharge the groundwater table. You just see the entire water, you just imagine that is a rainwater, and the entire water, it is coming, percolating from the specimen of pervious concrete, and it is reaching to the ground. So it is nothing but a no fine concrete. So it can be adequately used at the parking areas. Even that pervious concrete, we can design up to M20 grade, so that any parking lots, any walkways, jogging tracks, and any central park lawn areas, we can design this permeous concrete so that definitely the water table can be survived. As we cannot produce water, it is only purely dependent on the natural resources by the given by the gift of God only. So with this, I want to conclude my today's presentation. And once again, I thank Dr. Girish sir and Prakash Rao sir for this wonderful opportunity. And I am also, I want to put a note, as all are having an eminent speakers, professors has been part in yesterday and today. But I am an industrialist. I am not at all a teaching profession. If any mistakes, anything there, please kindly excuse. Definitely, I'll improve further and I'll get good deliverable. Once again, thank you so much for your patience listening, sir. Thank you.
Yes, sir, thank you. Thank you very much. It's very nice presentation, sir. Thank you, sir. Always. This is we are doing a couple of times already with Ravi Kumar sir. This is Krishna KNS Prakash Rao Garu, convener of Tribhuvan AP.
Yes, sir. Since sir, you are the industrial forum, please, sir. Actually,
yes,
myself,
sir.
And,
Yes, sir. Please, sir.
Sir, tell me, sir.
Please, sir. Yeah. Really, we are very thankful to you, sir. So it is a very nice presentation, and thank you, Ravi Kumar Garu, for giving a very good info to all the members. Actually, this industry institution interaction forum is mainly meant to persons like you. So because we the academicians need some practical aspects or visualization. We need it. So I'm sure you did the best, and thanks a lot for the delivery of nice presentation. So absolutely very good presentation, sir, with all the videos, etc. Really wonderful. Thank you once again, sir. We need your support in future as well.
Sure, sir. Definitely,
so that your practical exposure will be should be helpful for the student community as well as other practitioners.
Yes, sir. Even I am closely involved into the AP SSD cells, sir, AP Skills Development Center. So I'm
very good,
weekly
sir.
once I used to take the classes also.
Very glad, sir. So I will take the contact numbers.
Sure, sir. Sure, sir. Sure, sir. Sure, sir.
Yes, sir.
And any Q&A, definitely I'll pleasure to answer the Q&A also, sir.
Yeah.
Very glad.
Thank you so much, sir. Thank you for your valuable insights, sir. Thank you, sir.
Now we request the participants to ask
other questions. Question session.
Yeah, we have 5 minutes more.
Okay. Any question session, sir? Anybody? Any of our
audience can post their queries either in chat box or you can unmute yourself and ask.
Is a request any questions. Once the questions is there, then we can have the gauge the session. If the questions are not there, I can gauge my session is weak.
Yeah. No, people understood very right.
When the presentation is very good, then there will not be any questions, sir. When the presentation is very poor, then also there will not be any questions. But in between only some questions will rise. So anyhow, Ramchandra Reddy garu from Kaki, is there any questions, sir? Mr. Subramaniam?
Yeah, maybe. Actually, yeah. Sir, thank you very much, sir, Ravi Kumar, sir, because you have to go to Vizag now. Still, we are able to stay for us because of personally or staying back and giving.
That is purely the association with Dr. Girish sir, and even the Beaver sounds a lot to me. That is the major thing.
I'm very much thankful to you, sir.
Thank you so much.
So whenever I call, you are coming to us and giving a lecture for us. We are doing
thank you so much.
Yeah.
It's
we will end up, sir. Yes.
It's my pleasure to associate, and thank you, Prakash Rao, sir. Definitely, I'll be in touch with you, sir.
Yes, sir. Yes, sir.
Prakash Rao, sir, it's getting late for the speaker also. We will close the session, sir. We'll take. We will close.
Yeah,
Okay.
yes, sir. With pleasure, with pleasure. Yes, sir.
Yes, yes. So you
Yes,
want to
sir.
conclude anything, Prakash sir? You just conclude
No,
and
no.
give conclude remarks. Then.
Sir, really, I'm extremely happy, sir, the way in which Dr. Ravi sir, Ravi Kumar sir has delivered the talk. And in fact, I request you to kindly spare some time like this, sir, so enlighten particularly the student community as well, including the practicing engineers also. So they are supposed to have a good input, sir, so that then only real quality structures can be maintained. So we wish to conduct such programs periodically. Now and then we used to disturb you, sir. Please kindly spare your valuable time, Ravi Kumar ji, so that ultimately the society will be benefited and with all your knowledge and exposure and experience, sir. And really very thankful to you, sir. And I also thank our Girish Kumar for very dynamic,
such a dynamic
dynamically
person.
organizing this one. Yes, sir, yes, sir. So all the sessions are extremely good, really. I'm sure the performance of all the student volunteers, students, etc., is extremely very good. And I take this opportunity to congratulate Sir Girish Kumar ji, and also I am thankful to you, sir, on behalf of CIF, as well as on the Department of Civil Engineering. Thank you, sir. Thank you very much, sir.
Thank you very much.
I take this opportunity to suggest the student community. It seems a very good number of students are there. So I'm sure you are very lucky enough to have a very dynamic head of the department who is very, very keen to give some practical visualization to all of you and take this as an opportunity. So, because if you, after completion of your course, if you just enter into the industry, you should not feel you are novice. So, please attend all these sessions very carefully and try to grab something, and so that you can prove your talent there. So, yeah, I'm sure a civil engineer, Royal Civil, I can say, as you are supposed to prove yourself as Royal Civil. Thank you. Thank you, sir.
Thank you. Thank you very much, sir. Thank you very much.
Thank you very much.
Yes, Ravi Kumar, sir. We will meet once again in the next plan. Another.
Thank you. It's pleasure.
Yes,
Always.
yes, sir.
Thank you. Have a good day to you all. Thank you so much. Thank you.
Yeah,
Thank you, sir.
Thank you very much, sir.
Thank you, sir. Thank you for sharing a valuable information with us. Feedback link is posted in the chat box. Kindly fill the feedback. Thank you all for participating in all the sessions. Certificates will be provided for you all within a week. Thank you all once again.
Yeah, very good.
Thank you so much. Thank you.
Thank you. Thank you, sir. Thank you, Ravi Kumar.
Thank you, sir.
Thank you so much, sir.
I wish all the best. Yeah.
Thank you so much.
Yes, Girish ji. Yeah.
Yeah,
So,
I wish all the best,
let us
Prakash sir,
discuss
for
later.
for IIIF forum to move on with this with this program, and hope you will conduct many more programs for the benefit of for the benefit of many people.
It is a very yes, sir. It is really a good beginning. I am confident with the support of persons like you who are very much enthusiastic to the academic and go moreover with very good insight. I'm sure definitely we can bring many people, practical people into our forum, so that the students as well as the faculty will reap the benefits, sir. So I am getting very good feedback from all the other members, Institution of Engineers members, so that they are praising both the 2 or 3 sessions like anything. So I will try to send their feedback also, just in the form of messages.
Thank you. So whenever it is needed, my support and help will be there, sir. Please communicate. Thank you. Thank you very much.
With pleasure, sir. With pleasure. Thank you.
Yes, sir.
Yes, sir.
Yeah, right, sir.
Thanks.
So thank you all the participants for your wonderful patience for all this entire program. So we will meet once again, maybe in the next kind of a platform. Yeah. Yes, sir. We will leave, sir. Yeah, we will leave, sir. Yeah, thank you.
Yes. Yeah. Yes, sir. With pleasure, sir. Thank you.